can't tell you guys how many times so far this year from just my classes, I've already gotten emails from people like, Mr. G, I just don't have enough time on the quizzes. Mr. G, I don't have enough time on the test. I feel rushed. If you'd given me 20, 30 extra minutes, I would have been able to get a better grade, et cetera, et cetera. And I understand all that completely. But you have to remember when the AP exam is going to be administered later in May, they only give you basically like 2 hours. So you can't ask College Board, hey, can I get a little more time on this? So these calculator techniques should save you guys, almost minutes that you can use later on other problems that you need to think about. So remember, now that we've shown you all of the, now that we've shown you guys all of these, where all these tests are located, you can use these on any one of these problems anymore. So I'm not saying you can't use these formulas to go back and look at the stuff we did on Unit 6. Just make sure that you're still writing out all of the steps like we did on Unit 6 for this class as far as practice. But on the AP exam, if I'm taking the AP exam in May, all I have to do is make sure that I tell them what test I'm doing, make sure my assumptions are covered, type everything into the calculator, say, here's my calculations, boom, here's my conclusion. So these things that used to take us, 10, 15 minutes to do should be down to like 3 or 4 minutes if we're running things. And that should save us time if we've got to do a full-on hypothesis test or confidence interval on the AP exam for any given reason. They don't tell us exactly what kind of problems are going to be on there, so we're just preparing a little bit for everything. Anyways, I just want to go through this. This is your notes that you guys should have watched the video on yesterday, but some of you guys may have slept in and forgot, so I just want to go through some of the important things here real quick and make sure we're all on the same page. So the notes for yesterday, we're talking about 2 sample inference with means this time. So the one we did the other day was with proportions, that's the percentages. This one is looking at averages. And with this one, the goal basically is the same as the percentages. You're no longer trying to find what the true population proportion is of one sample and say, hey, it's anywhere between this and this. What you're trying to do is now say, I've got these 2 samples. What's the population difference average between the 2? So anytime you're looking at 2 things, especially in this class, we're doing comparisons. We're not looking just for the answer of one group. We're looking for the difference between both groups. So keep that in mind as you're doing these confidence intervals and these hypothesis tests. You're looking to see what's the average distance or difference between the 2, or for a hypothesis test, you're trying to see if there's enough of a difference in there for you to, reject or fail to reject, whatever. So it's no longer like Unit 6 where you're just looking specifically at one. We're going to assume for all of these that we have independent samples from each treatment or population. So that's going to be important when we do our assumptions here. So what are the assumptions? Well, there's only 2 of them on this one, just like before. The first one is you're going to say they are random because why? Either you have 2 random samples that are independent of whatever, or like our first example in the notes, we have 2 randomly assigned treatment groups. All right, so that's going to be your first assumption. So the first thing you write after your title of your whatever test you're doing, you're going to say assumption number 1, random because both of them are whatever. And then for the second one, remember when it comes to averages, we need to be able to prove that things are normal. This one is different than the percentages. This one's the one where it has to be given, or sample sizes are at least 30, or you have to graph both sets of the data. A disclaimer on the second option here, if both of them are greater than 15, well, 15 plus 15 equals 30. So we can say on the 2 sample test, that's good enough. All right, so they both don't have to be 30, just the total has to be 30. So that'll be okay on this one. 30 is still the best, but if you get above 15 on both, you can get away with it this time. And then if you're going to have to do the graphing route, you need to make sure you label, if you don't want points off on your AP exam and testing here, which graph is which. Don't just draw both graphs and say, yeah, they're both good. I didn't know which one's sample A, which one's sample B, or whatever they're labeled. And we don't have to use assumptions number 3, just like we didn't have to use it on the percentages. This has already been kind of established up here in the first one. So how do I know if I should use Z procedures or T procedures? Because we've got both, right? Whenever you're doing percentages, always use Z. And the program and the calculator's got you covered on that one. When doing averages, you use Z if you know the standard deviation of the populations, and you use T if you don't, just like before. Real life scenario, we're going to use T most often because in real life, we don't know stuff about the population. So I always tell my students, if you're going to make a mistake, make the mistake of doing T when you should have done Z. Don't make the mistake of doing Z when you should have done T. Reduce the chances of yourself being wrong. Assume that it's T for these, unless it says somewhere, this is the population standard deviation. And you'll know if it says that because it'll say, this is the expected or this is the population one. then you can go, okay, I'll switch to Z just for this sample. But most of the time we're going to use T. All right, what about degrees of freedom, Mr. G, for these things? We've got 2 samples going on. How do I do degrees of freedom if I'm using my T-score? Option number 1, if we didn't have a calculator, we would use the smaller of the 2 values. So we'd have a sample for number 1 and a sample for number 2. We'd figure out which one had the smallest number and minus it by 1. So if we had like 12 from the first sample and 15 from the second sample, then we would take 1 away from the 12 and degrees of freedom for the whole thing would be 11. That's option number 1. We do this because this produces the most conservative results. We don't want to be aggressive in our assumptions. So this will lead us to have higher p-values and lower confidence. However, since we have calculators, we're going to use option 2. It's approximated by technology. This nice, fun looking formula that you guys can't wait to do, don't worry, you don't have to, is inside your calculator. It does it all for you. And it's going to spit out a degrees of freedom. Now, the risk with the technology is this, and this is going to be the exact opposite of everything else we've done earlier, is it's going to give you a decimal answer for degrees of freedom. What the heck, Mr. G? So now we're going to actually round down on all of these regardless of the decimal, just because we like to confuse you. So we round up on sample size, but we round down on degrees of freedom. So there we go. Yay, more confusion. Thank you, Mr. G. But our calculator will do all of our degrees of freedom for us. So, you know, I don't have to go back to there and do it myself. All right, there's our formula for the confidence intervals. You would, in real life, if you're doing this on paper, take the first sample minus the second sample to get your difference, and then add and subtract that to whatever your T-score is, and then all this fun standard deviation stuff on the end. You'd have 1 standard deviation over 1 sample size and the second standard deviation over the second sample size. Again, remember, we have the calculator, so we're not going to actually do these formulas. But if you guys like to do stuff by hand, go back later. If you got free time and you're extremely bored and all your Netflix shows have been watched, you probably want to. This last part, again, is called the standard error. It's the same thing as the standard deviation. For the hypothesis test, we have a fancy formula too, and it's built in there. And here's Mrs. Nichols' sarcasm. G, it looks nice. It would be nice if there is in the calculator. You guys know that it does. So I'll show you which one it does so that we can kind of circumvent all of the hard work. What do I actually have to put on my work for the AP exam? This is the exact same list we went over the other day. Make sure you still have your hypothesis for the hypothesis test. Make sure you state the name for both of them. Like, I need to know which one you're doing. Make sure your calculations are labeled so you don't actually have to do the formulas, but you should still have like the T-score for the test statistic or the Z-score for the proportions or the degrees of freedom or whatever. I'll show you guys in my notes what I'm talking about, but they need to know what your final calculations were that came out of the calculator. And then make sure you're writing your conclusions for either one. That's still necessary. So assumptions and conclusions still need to be on. Here are the exact things you need for the means for the what's going to be written down. So for confidence intervals, you need to just have the interval, just like before. And the degrees of freedom, again, rounded down this time. Don't worry about what the decimal is, just whatever the whole number is, keep it. For the hypothesis test, you'll need to display what the T is or the Z, but most likely T. Degrees of freedom, if it's applicable, again, rounded down, p-value, and what your alpha was for the test. So this way they can basically see you had this T-score, you had this p-value, you compared it to this alpha. They can check all your calculations and give you full credit. They know you know what you're doing. If you call the test or interval by name, you don't have to write down the formula. So that's why I'm trying to encourage you guys highly. Write down 2 sample T interval, 2 sample T hypothesis test. Put that on there. Otherwise, you got to write them stinking formulas out that have X1, X2, plus or minus. And nobody wants to do that. The big time saver. And like I said earlier, for those of you guys who just joined us in class, I've gotten several emails this year about how you feel like the quizzes and tests have been rushed and you didn't have enough time. And if I gave you 15, 20 extra minutes, you would have done great. And I completely understand, 100% agree, but we're trying to stress test you a little bit because your AP exam is not going to have extended time. And so anything you guys can do to save time to get answers quicker, I want you guys to do it. So writing down the name of your test is much quicker, trust me, than trying to remember and look up all the formulas and write down all of your steps. When it comes to pooling in real life, we would have to pool the variance for both of the samples in order to sit there and do everything. When you pool, you average the 2 sample variance, estimate the common. Do not use it on the AP exam. So we're going to say, just say no to pooling. Just say no to drugs. Just say no to everything, children. It's no fun. All right, so go ahead. And Mr. G is kind of crazy today. I didn't teach us. So. All right, let's do one together. Make sure you guys are good to go in your notes. I know some of you guys watched the video and already have it, but let's make sure we're all on the same page on how to do it. So 2 competing headache remedies claim to give fast-acting relief. An experiment was performed to compare the mean lengths of time required for bodily absorption of brand A and brand B. So you guys can see they're running an experiment with 2 samples, They want to know the difference between the two. They don't want to know what A's is by itself, and they don't want to know what B's is by itself. Which one's better? 24 volunteers who get headaches were used. 12 people were randomly selected and given an oral dosage of brand A, and the rest were given an equal dosage of brand B. Length of time in minutes for the drugs to reach a specified level in the blood is recorded. Here's our important thing. Assume absorption is normally distributed. So the results are below. It's nice when it's in a list like this because then you don't have to go back and hunt for them. So there's our two averages. There's our two standard deviations. There's our two samples. So find a 95% confidence interval for the difference in mean lengths of time required. So for our calculator purposes here, we want to go to option 0 in the calculator. So if you want to put a little option 0 next to this to make sure you're using the right one, I would do so. Let me get my calculator or camera going. So this is not second bars, I'm sorry. We're in stat, go over to test, option 0. 2 sample T interval. So why is Mr. G using a T test on this one instead of a Z test? What do I not know about my population? Standard deviation, very good. Didn't say anything in there that the population's what its standard deviation is expected to be, et cetera, et cetera. So like I say, watch for that stuff. All right, that's good enough. All right, so we go there, we press enter. You're gonna see there's your stuff to type in. I already did it earlier to make sure I was doing the right thing before I mislead you guys. Where you're typing in stats. So sometimes you can type in data, sometimes you can type in stats. So later on, if we get a problem that's just got a list of crap, then we can use the data. But this one, they gave us stats, so we're gonna do stats. So sample number 1 had 20.1 for an average and a standard deviation of 8.7 with 12 people. Boom, boom, boom. There's my first one. Sample number 2 had 18.9 for its average with a standard deviation, of 7.5 and a sample size of 12. What confidence interval do we want? 95%. Remember, we don't have to be fancy. We can just type in exactly what we see, EA technology, and just say no to pooling, children. Don't do it. All right, everybody good? Questions? Press enter. There's your answer. So I know that the average difference between the two is anywhere from negative 5.685 to positive 8.0854. With the degrees of freedom of, wait, what? A decimal. What are we going to round it to? 21. It's always going to give us this weird decimal. So we have degrees of freedom of 21 here. And then it reminds you of what your sample size is, standard deviations, and all that fun stuff is. All right, so what does my actual notes need to look like, or homework, or whatever, so I get full credit, Mr. G? I just want my grade to be good, man. Don't give me all this other stuff. No problem. Here's what it should look like. Come on, camera. Cooperate, Mr. There we go. I don't know what this little like reindeer thing is doing. All right, so first things first, I have to label what kind of test am I doing? A 2 sample T interval. Okay, that or I'm writing the formula. This is easy. What are my assumptions? Random because we have 2 independent treatments randomly assigned. Normal because it told me. All right, so there's my assumptions. Check, check. What kind of calculations do I need? Just 2. I need to know what the interval is, and I need to know what the degrees of freedom are. I put 21. Why? Because I do what? Round down. Very good. But Mr. G, we always rounded up before. Yep, on the other one we did. So that's going to be confusing. So it's going to take practice. So round down on this one. But this is a 0.5 on him. I talked to math teachers yesterday when I did the SAT with them, and I told them we'd drive them nuts. So what's my conclusion? We are 95% confident that the true population mean absorption time for brand A minus brand B is between boom, boom minutes. Don't forget your label. Question. Again, if you watched the video yesterday, you probably already got this. I'm just reviewing to make sure everybody's on the same page as far as typing stuff into the calculators. So I'm going a little faster than I normally would because I'm not doing this like from scratch. I am recording this video though, so you guys can compare which one you like better, my version or his version. All right, everybody good? All right, for the last step, I'll put the slide up in a second. Based on your confidence interval, is there sufficient evidence to say there's a difference in mean absorption time for brand A and B? No. Why not, Mr. G? I see different numbers there. Because 0 is included in my interval. So remember what I told you guys the other day when we did a single sample, we needed intervals to be above or below 50% to make a difference. Because we were looking at, did it increase or decrease? For this one, we're now looking at, is it positive the whole interval or is it negative? Because if there's a both, basically, if our interval has both negative and positive numbers, then we have no actual conclusion on what the difference really is. It could just be nothing. Zero fits right inside there. And so if there's zero difference between the two, we're not going to recommend brand A versus brand B or vice versa. So if we had all negative numbers, we could say that brand B was better. If we had all positive numbers, we could say brand A was better, but we didn't. So for those of you guys in the medicine field, if you do these type of things later, again, I don't know, I'm not in medicine, but if you guys go into that and you're comparing samples of people's medicines or whatever, if you're looking at differences, all negatives mean that your first sample was worse than your second sample and vice versa. All right, so does that kind of help make sense? Clear up some things? Again, I don't know if you guys watched the video yesterday. If you just slept in completely and did nothing, that's fine. Like, I don't really care. I just want to make sure you guys are all on the same page for our test coming up. They did your attendance for me, so if you got a problem with the attendance, you go to the attendance clerk when you get to the high school. I went yesterday afternoon to go check. They were all populated. Okay. All right, everybody good? Anybody still writing? Everybody's good. All right, so let me go back to the slides because the print is much easier to read than my chicken scratch. Boom, 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 boom. There's everything. Explicitly define which way you are subtracting in the conclusion. Typically, we're doing A minus B. So whatever you put in first, you're subtracting the second one from in the calculator. So for some reason, you'd put B as sample 1 and A as sample 2, then you would need to flip your conclusion to say B minus A, and your interval may or may not be different. It depends on how you type it. So most of us go in alphabetical order. So if you're curious, just pick that direction. Make your life easy. All right, there's the other thing. Follow-up question with the interval no. There you go. The results are inconclusive. That's what it means when 0 is in there. All right. So as a side note, I didn't write this on my paper, but as a side note, if you're curious, we would have failed to reject the null hypothesis if we were comparing it on the hypothesis. We would not have conclusive evidence to say one brand is better than the other. We didn't do that, but if we had run the hypothesis test, that would have been the case. All right, so what about if I'm doing a hypothesis test, Mr. G? What are my sample or what are my statements? How do I write this thing out? They're listed on your notes there. So you would say that for the null hypothesis, if there's no difference between the two that equals 0, then you can write it as sample 1 and sample 2 are equal. And then you just have to decide which way you're testing. So if you suspect that sample 2 is bigger, meaning you're going to get numbers less than 0, then you'll write it as that. If you suspect that sample 1 is bigger because you get positive numbers, then you do it that way. And it'll tell you in the word problem too. We're looking if it's greater than, less than. Or if you're just looking for them to be different, then you would write it like that. So these are what you would write. This is kind of what's going on behind the scenes. Be sure to define both of them. So what does average 1 and average 2 stand for? Okay, so make sure you tell everybody that like we did before. So there's going to be 2 sentences. Here's your nice fun formula that I would normally make you do, but we don't have to do it. We got the calculator. So we'd say T is equal to the samples minus each other minus the population average. Remember, this will just be 0 because we assume there's no difference between them. So that never really exists anyways. And then we'd have the 2 standard deviations over the sample sizes underneath the square root at the bottom. But again, we have technology, so we don't have to do all this stuff, but this is the formula you would use. All right, so looking at example number 2, the length of time in minutes for the drugs to reach a specified blood level was recorded. Oh, these look very familiar. Yes, it's the same sample. We're just now running the hypothesis test. Is there sufficient evidence that these drugs differ in the speed at which they enter the bloodstream? We already know the answer. Right, the answer is no, but we're going to prove it with our hypothesis test. So don't forget your label. It's a 2-sample t-test. All right, so if you're looking at your calculator, which one am I going to do, Mr. G? This one is going to be 2-sample t-test, option number 4. So put a little number 4 next to it if you want to use it later as a review to go back. Okay, which one am I doing? I'm doing option number 4 on this. All right, there's my 2 assumptions. 2 independent randomly assigned treatment groups. The absorption rate is normally distributed. Both are given. We said this last time. Here's my null and alternative hypothesis. 2 seconds. I got to shut my door. I think I have a meeting. All right, so there's my hypothesis. We are assuming there's no difference until proven otherwise, and that's what we're looking for. All right, where again, average A is the population mean absorption time for brand A, and average B is the population mean absorption time for brand B. So I'm on example 2, writing my assumptions. All right, so when it comes to the information that you get from the calculator, this is what you need to write down. So I'm going to show you guys how to type it in and make sure we're all on the same page. I think I got all my numbers here real quick, make sure I'm good to go. 20, 18.9. Yep. 8.7, 7.5, yep, 12, 12, 12, and we're checking for it to be different. Okay. All right, so let me switch to the camera real quick so you guys can see. All right, so I went to option number 4. Again, I'm inputting statistics. I'm not doing data. I don't have a list. I have, even though it looks like a list, I actually have statistics. So for the first one, brand A, it has an average of 20.1, a standard deviation of 8.7, and a sample size of 12. Boom, boom, boom. For brand B, it has 18.9 for an average, 7.9, 7.5, sorry, for a standard deviation, and a sample size of 12. What are we looking for? That they're different. So we're going to flash the first one here. Average 1 is what? Different than average 2. Not greater than, not less than, different. Again, just say no to pooling and drugs. Make it a different color if you like a different color. Calculate. All right, so you need to show what the T is, the p-value, which is this one. Remember, it doesn't say it in here, so you got to write out p-value equals. There's my degrees of freedom. Again, what do? We round down. So just basically whatever whole number is there, guys. And then it reminds you of all your stuff you typed in down here if you need to go back and review it. So those are the things you need to have for your calculations. Also include your alpha. So what are we using for alpha on this? It doesn't tell me, so 0.05. All right, so that's where I get it from. Are we okay again with the calculator? It's new. That's really the only thing that's different. So I want to make sure you guys don't have any questions. All right, let's flip it back to the actual text that you can read better. All right, so there's my calculations from the calculator. T-score, all right, so 0.3619, there it is, I see it. Rounding to 4 decimals works. Degrees of freedom should say 21. I'm gonna get you this nickels later. I just saw that. P-value equals 0.7210. And alpha is equal to 0.05. So I get to see something that Miss Nichols didn't do. That. It's fun when I get to point out mistakes that she does because I make them all the time. Okay, any questions? All right, don't forget your conclusion. Since the p-value is what? Well, it's 7.2. That's a large p-value. Is greater than alpha. I fail to reject the null hypothesis. There is not sufficient evidence to suggest that these drugs differ in the speed at which they enter the bloodstream. Very applicable, very important, very relevant ways to determine if you got 2 different drugs you want to give people if they work or not. You can do this with the vaccines out there. There's what? Pfizer, Moderna, Johnson & Johnson. Who knows how many? Pump one person, enough people of each of them, come back later and go, no, more of them got sick. Is there a difference? Whatever. However you want to do it. So for those of you guys, again, that are really into the medicine stuff, or whatever course you're going to go through, you're going to use this. Or somebody's going to do it for you, and you're going to have to be able to read the results. Okay, so once you have all of that written down, that's it. That's your hypothesis test. So we can do a follow-up question here in a second to make sure we remember what we are looking at when it comes to what confidence interval are we using on this hypothesis test. Looks like everybody's got it. No, it's still could be right. And this is the last example that we had on the notes. You guys are pretty much all caught up. If you didn't watch the other video, now you're good. Starting tomorrow, we'll do the matched pairs. Matched pairs is a lot of fun because you're trying to see if there's any difference between things that you pair up, basically. We didn't use matched pairs very often in our experimental data way back in Unit 3, but we'll get to see more of it now. Just hope you work. All right, So follow-up question, if we created a 95% confidence interval, so on your notes, scratch off 90 and go to 95. There's all kinds of errors on this thing. Would we expect 0 to be in the interval? Yes, we would. And why? Because we failed to reject the null hypothesis. So remember, when you reject the null, you are saying that your sample does not fit within the expected interval. That's basically what you're saying. So we're saying these two means could be the same, meaning 0 is possible for the difference between the two, that drug A and drug B may have negligible difference. So that's basically what we're saying. So it should say 95% on your notes. If you got it, cross off the 90 for 95. Now, why did we use 95 instead of 90 that's on the notes? Well, remember, this is a question that got people on the test overall in general, so this would be a good time to review it. If we do a two-tailed, so over here and over here, different hypothesis tests like that, like we just did, with alpha equal to 0.05, right? That was our default. That means this area and this area equal this. So 5% of the area was used to determine if we had outliers total. Out of the whole graph, that equals always 100%. So remember, this whole thing always equals 100%. So if we used 5% of the data total on both sides, that leaves how much left over in the middle? There's my 95. And that's why it should say that on your notes instead of that. So that means 2.5% were on either side of my confidence interval that I was looking for outliers. And remember, as an experimenter, I can control alpha. Okay, so this goes back to our previous quiz. I can control alpha, make it bigger or smaller if I'm worried about type 1 errors. And we can go through the whole process. We're not going to, but we could say, what is type 1 error in this case? If that bothers me, then I'm going to reduce it and make alpha small. If I'm okay with it, I can make it a little bit bigger and reduce the other one that might be. I can increase sample size. I can, whatever. There's all sorts of little tricks I can do to minimize my errors, increase the power of my test, et cetera, et cetera. Now that we've done that, you guys can kind of look at it from that perspective now and see that these aren't just random decimals we're giving you to do math problems. These are actual legitimate scenarios that you can see why it's 0.05 or why it's 0.1 or whatever. Anyways, that's it for these sets of notes. Any last minute questions for me before I let you guys go for the morning? Yeah, again, I hope you guys got to sleep in a little bit yesterday. It was nice. I got to sleep in for an extra hour, which doesn't seem like much, but when you're always waking up at like 6, it's nice to sleep until 7 and then not have to worry about teaching lessons and stuff early in the morning. So hopefully you guys had a good day yesterday. We only got tomorrow to do and you're back on the weekend again, so that's good. For those of you guys still wanting to do your retakes for the multiple choice section of Unit 6 test from like earlier in the month, I'm going to start averaging scores on Friday. So whatever your highest one is, about Friday afternoonish, I'm going to start putting them in the grade book as your new grade. So if you're already happy with your retake score and you've done a little bit of math by adding 2 together and dividing by 2, then you're good. You don't have to do anything else. If you still want a higher grade for your retake, remember you get 3 attempts. So after your third one, that's it. So don't do them really fast 3 times. Be like, well, I got like 40s on each of them. All right, so come see me for tutoring. If you've already done 1 or 2 of them and they're not good, don't try to burn all 3 of them really fast. And like I said, I'll start averaging those together for you guys on Friday afternoon. That way before the weekend, hopefully, unless something happens between now and then that causes me to get distracted, you guys can have that grade taken care of. If you still need to do the free response, whatever, reach out to me, let me know. I'll get it unlocked for you. We can go over whatever you were missing on your previous one and get you all set up. Miss Celine's here. Don't say anything about it anymore. What's up, Miss Celine? Is what and what? Is Canvas working? Mine is. Guys at home, is your Canvas working okay? Okay, maybe it was working like as of 5 minutes ago when I loaded this up. But all my classes get to do work today. Yes, Miss Misha, I can open up your, are you talking about the FRQ? Yes, ma'am. I'll take care of that for you. All right. You guys have a good rest of your day. If Canvas isn't working, then I don't know. Figure out what you're doing. We'll see you guys tomorrow morning at 7:20. We have matched pairs notes, and then our practice quiz over all this stuff will be sometime next week, Monday or Tuesday. But it is a practice quiz, so don't stress about it. All right, guys. Have a good day. It's good seeing you again.
Bye, Mr. G.
Bye. We'll see if it'll let me go in and do stuff. Let's see. Oh, there's no work. Nope. Canvas is dead. Everybody going.